Hey everybody, welcome. We'll give it another minute, just let everybody else that's joined us. We got a really good crowd that registered from all over. Our webinars, we've had people attending on our webinars all over the world, from Australia to China to India to you name it, different parts of the world. So that's what's kind of fun about the online training shift in the midst of the pandemic. So welcome, no matter where you are on the planet. Well, it is noontime here on the East Coast. Like I just said, people are tuning in from all over. I know we've had people listening to our webinars in the middle of the night, no matter, depending on where you are. But the great thing is, no matter where you are, we can do training like this. But let me give you a little bit of an overview. Actually, I will say, welcome if you were on yesterday's air monitoring webinar series, part 1. We had a whole bunch of people register within the last 24 hours. So if you missed yesterday's part 1 series, it was an excellent webinar. But kind of, look for on our website on EnviroClass, we will probably have some future air monitoring webinars. So if you missed part 1, we'll probably have those speakers again in the future. So my name is Travis Bowman, and let me tell you a little bit more about the training we do for environmental professionals. Typically, we are doing an in-person workshop, and so the Enviro workshops, whoops, my slides are moving on me. We have hosted actually close to 400 environmental workshops around the globe in 20 different countries on 6 continents. I like to joke and say the only continent we haven't been to is Antarctica, and I don't know, maybe those penguins need some training down there, but I don't think we'll get to Antarctica anytime soon. But the rest of the continents, we've been there. And we've seen over 20,000 environmental professionals registered. Normally, in a normal year, obviously this is not a normal year, but typically we would host about 70 workshops each year. And of course, today it's focusing on air monitoring, but we also do training for the remediation segment of the industry, vapor intrusion, and also wastewater. And so, and different themes continue to emerge as we do training for environmental professionals. So, but I will say you can check out our website. Enviro Workshops is a different website than Enviro Class. But obviously, in the midst of the pandemic, we've shifted to this online platform, and so Enviro Class is really a new platform for our webinars. And so at the end of today's webinar, you'll get an email from Faith Woodard. Give her about just a couple hours, and she'll get a certificate to you emailed this afternoon. With your name on it. And but what we found is the engineering boards that approve continuing education credits, they like to see that you're answering some polling questions. That's kind of like a sign in and sign out sheet. So after each of the speakers today, we'll have a couple of questions, and it's just really making sure you're engaged as you're learning today. So look for those, and then after the webinar later today, you'll see an email with the certificate from Faith Woodard. Well, if we were in person, we'd actually have a printed program for you right there on your seat, and we would, be a place for you to take notes. Well, we do have that here on your control panel on the right side of your screen there. If you scroll down to handouts, you can click on the download now. That's just a PDF that we've got. So we've got the different speakers' bios on there, and so I'd encourage you just go ahead and download that, and you can see a little bit more about the different sponsors, even the ones that spoke yesterday. So they're in that program. So download that, and you can use that for today's webinar. Well, the other thing that we've done in the midst of the pandemic is we launched the Enviro Talk podcast program. And so really it was a way for our sponsors in the different markets that we do training, just for them to talk about what they're doing in light of COVID-19 and how they're meeting the needs of their customers. And so I think if you go to our website, Enviro Talk is just one of the links there, but you can find that on our website. But you can see, I think we interviewed about 20 of our different sponsors, again, just kind of giving them a voice. So each program is about 10 or 15 minutes. Wherever you might download podcast programs to, just type in Enviro Talk, and it'll pull up on your phone or wherever you typically might listen to podcast programs. So there's that. But then the other thing that we've done, now that we've gone around the globe with our training, is we've been working on the 2020 Global Enviro Summit, and it'll be hosted right here in Charlotte. I say here because that's where I'm based. But Charlotte, North Carolina, September 1st, 2nd, and 3rd. We'll have speakers from around the globe. speaking from Africa, from Asia, from the Middle East. We've got a speaker from Kuwait and from Tel Aviv, from Israel, but we've got them from all around the globe. But then also we have breakout sessions that are focused on remediation, vapor intrusion, wastewater, air quality. So take a look at that website, envirosummit.com, and get a little more details. We've had a call for abstracts for most of this year, and we're just now going through the fine-tuned details of who will be speaking in each of the breakout sessions. So feel free to take a look at that. Obviously, in the midst of COVID-19, we've put together a task force, and so Chris Harden is our task force leader, and we've been working with the governor's office here in North Carolina and the Mecklenburg County officials, the senior health officials, to pull together a COVID-19 compliance conference. So for those who want to be in person, we will be there in person. We've got a 4-page compliance document that we're working with Mecklenburg County on, and then we'll also offer a virtual registration as well. Interestingly enough, Brian Whitley, one of our speakers today, his brother Jay Whitley is working with the NBA on what it takes to get back to doing games into the fall time with doing it in a healthy and a safe way. So I've been talking with Jay as well about doing our conference here coming up in September in a healthy and safe way. So, well, find us on LinkedIn. You can see the details on the Global Summit on our LinkedIn page there. So if you just type in Enviro Summit on LinkedIn, I think you have to actually type Global Enviro Summit, but you can find us there, look for us there. And then also the Enviro workshops on LinkedIn. And so our fall schedule that we'll be rolling out here too. So find us there. Well, a little bit more about our speakers today. Jordan Laster is the Vice President of Analytical Services with Alliance Source Testing. If you're not familiar with Alliance Source Testing, which I think most everybody is, but they're the largest stack testers in the US. But Jordan holds a bachelor's in chemical engineering and chemistry from Vidna University. Jordan, you have to correct me on that. Whitney University. And he's been involved in stack testing for over 12 years, split between laboratory and analyzer manufacturing and good old-fashioned sampling. The bulk of his experience is focused on complex sampling situations in organic work with a special focus on UV and IR spectroscopy. He currently serves as the technical director for Alliance, NELAC, accredited laboratory, and oversees the unusual and custom test programs nationally. In his free time, Mr. Laster enjoys baking and teaching martial arts, but he has not yet perfected doing those simultaneously. That's good. I like that. I was going to ask about that, Jordan. I was wondering if you could do that simultaneously. And then Brian Whitley is like who I just mentioned. His brother been working with us on our global summit, but Brian Whitley has been he's the vice president of compliance for EMSI, and he's been on the LDAR professional for over 28 years with experience ranging from M21 monitoring to expert witness reporting and consulting for the US EPA. Brian has conducted extensive program audits, negotiated consent decree terminations, and has managed hundreds of A-rated LDR programs from start up to compliance. Brian currently serves as the corporate compliance manager for EMSI, where he oversees the regulatory compliance of facilities all over the United States. A little bit of disclaimer in case you might have gotten an email about today's webinar and you thought maybe both of these speakers were kind of doing a presentation together. If you were on yesterday's webinar, that's what those two speakers did. They kind of were sharing the same presentation, but Brian's presentation today is really more focused on lightening up your budget without compromising compliance. And so I won't read all of that, but Brian, I want to make sure you saw that these two speakers have different presentations. And so he'll be really focusing on the LDAR program and that sort of thing. So two different presentations today, just so you know. Next week on the Enviro class webinar series, we actually have 3 different webinars, not at all focus on air monitoring, but I wasn't sure who you all are interacting with maybe in your office. So on Tuesday, we have a webinar on vapor intrusion, so selecting the right equipment. On Wednesday, we have another one on vapor intrusion and the laboratory analysis. And then next Thursday is actually a new testing that Pace Analytical has come out for COVID-19 and wastewater testing. So Vice President Johnny Mitchell from Pace Analytical will be giving that one. So wanted to kind of give a little bit of what's going on next week. Well, that is my intros, and looks like my slides are still advancing, but Jordan, I'm going to go ahead and hand things over to you and let you get things going here with your slides. And Jordan, you're still on mute, by the way. I tried, oh, there we go. Now you're unmuted.
Alrighty, let's close up here. All right, and
there you go.
All right, thank you, Travis. Thank you, everybody, for joining us. My presentation really ties in with some of the discussions from yesterday as well, focusing on mix testing and specifically HAPs testing. As Travis mentioned, Alliance Source Testing is the largest company in the United States that has a sole focus on stack testing. We have 13 offices across the country. We're set to mobilize just about every state except for Hawaii pretty easily. We even have an office up in Anchorage. So to jump right into this, for those of you who've been involved in stack testing, you're probably well aware of this. If had stack tests done, you understand that it is a labor and time intensive process. The critical piece is the pre-project planning in just about every case. There are many instances where a little bit more detailed planning could certainly save a significant amount of money. It can save delays and postponements, as well as lost production time if you have to produce certain products at certain times to meet the goals of particular tests. Now, in the case of HAPs, we typically recommend at least 2 rounds of these detailed discussions. So this involves some of the more complex and nuanced air emissions tests than you would typically see with other types of compliance parameters. When you're testing for HAPs, there's a lot more that needs to go into it to make sure you have an effective and successful stack test. So today we're going to address just a general overview of HAPs, potential complexities of these tests. We're going to give an overview of some of the key analytical approaches, and we'll take a deep look into some select technologies and select methods that may be applied for different tests. And we're going to address dealing with unexpected results. As you may imagine, as testing becomes more complex, you definitely have more opportunity for QA issues or results that then you're trying to compare to previous results, and there's a lot of questions that can sometimes arise there.
Hey, Jordan. Hey, real quick, Jordan. Your audio has been going in and out, and I've been getting people messaging me about that. And there is a phone number that you can call in, and then you just put your computer on mute. That might be a little bit more stable.
All right. This phone number is going to be in the meeting invite.
Yep. I can actually give it to you right now if you've got a number to.
Okay.
Oh, yep, you got it right there. That's it, right there on your email.
I apologize for this, guys.
Yeah, call that number right there, and then the access code. Do that, and just put your computer on mute, because it cleared up for a minute or 30 seconds, and then it went back to a choppy.
Pound or hash sign.
Sorry about that, everybody. It was perfectly fine. He sounded great when we first tested it. So, but he should be jumping back on here in a second.
You know, it's not.
Hey, Jordan.
Keep watching. You want to switch to Brian while I get this sorted, maybe?
Okay. All right. Hey, Brian. We'll get you teed up here. Hey, Brian. There we go.
Okay. Sorry about the delay, guys, and thank you for being here. So I'll just jump right into mine.
Rock and roll.
So the reason why I put this picture in here is because it was maybe a year or two ago, and I was giving a presentation. This time I had an audience, right, that I could actually see, and I was up on stage, and it was a pretty interesting time when this was going on. And I left a slide up there, and probably 5 or 6 seconds, I didn't say anything. I just looked at the audience, and I could tell you that the tension instantly was able to be cut with a knife. And the crowd was very diverse, and the people that we were looking at, or at least I was looking at, like the next words that came out of my mouth was going to be very, very, very critical. So anytime that President Trump has something to do with anything that I'm working on, then I love to throw this picture up there, even though I can't see your faces. I can only, you guys imagine like what's coming next. And so at the end of the day, the question really boils down to what does our president have to do with cutting a budget and not cutting compliance? What we want to talk about is administration. So I want to kind of paint a full picture, and it'll come full circle toward the end of the slides. But as we look at it, the Trump administration and he himself has referred to the US EPA as an impediment to business. And although we had to do major budget cuts at the beginning of that campaign and looked at everything that was going on, 1% of our nation's budget is allocated toward the US EPA, but it still actually received major cuts. And those of us in the industry kind of saw that actually happening with their lack of presence in places where we were used to seeing them. And if you want to add insult to injury, the people who were appointed to be over the energy sector and the US EPA were people who were known to have some issues with both of those departments they were respectively over. Now that's on one side of the fence, basically. So that side doesn't necessarily hurt us. In many ways, we kind of want to be able to move forward and push and progress. On the other side of the fence, we look and see what happens when the US EPA does vote in our favor, does grant in our favor. And this right here is a small excerpt of a long list, docket list of lawsuit after lawsuit after lawsuit. Suing, for example, on the first one that I'm looking at here, ExxonMobil permit number, this was the right to do an expansion. And that expansion resulted in not only Sierra Club, but the Air Alliance Houston suing because they didn't want that to actually happen. So if you can put yourself in a place of the EPA, not that we're always willing to do that, but we're looking at the wake of things like this. You know, on one hand, you're saying that your budget needs to be cut and you're an impediment to business. And on the other hand, everything you do to try to help business, there's this whole other group that's out there basically telling you that you shouldn't do that because we as the industry folk are trying to harm the environment. And you have to ask yourself quite often, like, where's the win? Like, this doesn't seem like anything is going to happen that will be able to make us move forward. Well, something horrible has happened in 2020. Obviously, we live it every day, this new norm. And in the wake of that, the US EPA in March relaxed the rules for monitoring and actually expressed openly and publicly that they would not be seeking penalty for the lack of the ability to be able to monitor in the wake of this pandemic. So if you had a B1 program or VOC or HAP program where you're monitoring volatile organic compounds or hazardous air pollutants, and you're unable to be able to do that, they were not going to seek penalty on you. This is expected in writing now to go through September 30th, 2020. So we have a very short window, but we were already in the process of working on quite a few things. And I just wanted to make sure that I made it available to all of you guys to be able to see, because what's in the wake of this is substantial cost savings. So we talk about where the win is. Right now, there's a unique opportunity for us to be able to demonstrate emission truths that we've long known to be the case. We have a stage in front of us right now that if we use it correctly, might actually change the course of how we monitor and handle our business from this point forward. Quite honestly, what I'm saying is that we have the technology and the analytics at our disposal, and in our industry, we're not taking advantage of it. If you look at how we know how well a pitcher can pitch in a game or how good a quarterback is going to be in a game, all of those things are done by predictive analytics. Believe it or not, if you're a social media type person, the ads that show up in your feed are based on predictive analytics. So this stuff is all around us, and there's more interesting ways that we can actually use it than what we're taking advantage of right now. We know that we're in a very hurtful time. Many of us have had situations that were near and dear to our heart that has caused a lot of problems. So I'm not by no means saying that this is some silver lining, but I am saying that it is an opportunity that would not hurt us as companies to explore. So if we work together in this situation right now, we can give ourselves exponential possibilities and savings for the future, for the long haul, in the other side of whatever this new normal is going to end up being. And the question really, I guess, that we're all asking right now is, okay, well, how can we do that? And quite frankly, I'm saying that we can reduce more emissions demonstrated by meter deductions monitoring if we just simply redirect the money that we're currently spending on our LDAR programs today. And we can accomplish this by placing our focus on components that actually leak. Now, I'm going to, as I'm still painting this picture, talk grandiose and big picture ideas. Did you say something?
Nope.
Okay.
Y'all good. Keep
Grandiose
on
and
Have a great one.
all right. Grandiose picture ideas of things that we can do, right? So we run these programs, they're mandated all over the United States. And we've always said that 90% of our emissions essentially end up coming from 10% of the components. And what am I really saying when I say that? Then I'm basically saying the exact opposite of it also, that 10% of the emissions, it takes 90% of the monitoring to get those done. There has to be a more effective way, because what we're really coming up with is that the monitoring process, the protocol, the way the rules are written right now are not, as we already know, cost effective. But none of us have ever really paid attention to how much wasteful time that we spent with the monitoring activities that we've had. So I pulled some data, and in this data that I pulled, it's been over like a 5-year period of time to give a well-rounded view of what all we were looking at. Each of these facilities that I want to discuss with you have been audited by the US EPA, as well as other third-party contractors. And honestly, my only reason for stating this is to validate the fact that this data is good. The monitoring quality is good. Therefore, we can kind of trust what we see. We've all heard that, if you don't put good stuff into your database, you're not going to get good stuff out of it. These are what they would say in Texas, a bona fide program, right? So the first thing I want to look at here is a refinery. So this refinery, if you're looking at this chart with me, you see that on the far right-hand side, that the blue represents the amount of components that we've monitored, and it monitored 50% of the components. We have captured 90% of the almost 90% of the emissions. But if you go all the way over to the left-hand side and you look at 1% of the components that we monitored, we had already hit nearly to the 40% mark. Or if you go into the middle and you see that at the 20% of the monitoring mark, we've already captured and collected 70% of the emissions. You can see where this waste begins to start. This is an example of a refinery. Let's look at a chemical plant. This is a standard chemical plant. I know there's hundreds of them out there, different types. But at the 1% mark, we've already over nearly 25% of the monitoring, 25% of the components that leaked. When we're looking at the 20% mark. At the 20% mark of our monitoring, we monitor 20% of the components. We're already at 60% of the components that leaked. So once again, we can see that there's a wasteful trend going with the amount of work effort that we put into it. Let's kind of, go into what we're really saying. Let me set the stage a little bit for us here. So facility one, this is another real life example. It's a C3, C4 fractionation type facility, and it has roughly about 40,000 monitoring components on a quarterly basis. And with that being done, that looks at over 160,000 monitoring events during the course of a year. So that's a lot of monitoring that we end up having to do. Question is, and this is one of your poll questions too, by the way, if I'm giving you a little cheat. How many of these components leaked at least once? These individual components leaked at least once in a 4-year period. So when you consider the 4-year period at 160,000 components to be monitored annually, that's over 600,000 monitoring events. So we've done 600,000 monitoring events. That's individual work events. Someone is out there actually performing that work to test that component to make sure that it doesn't leak or isn't leaking, and putting a program in place to get it fixed. We had just over 3,000 of those individual components that leaked. Just over 3,000. That's over a 99% ineffective rate in monitoring. And so right about now, I would hope that some lights are going off and we're starting to see that a lot of the work that we do can be put in the category as a waste of time. Before, we didn't know any better. Now, we actually have some ways to be able to do this a little bit more effectively. And that's kind of what I want to get into. So if you look at what the Sierra Club and Air Alliance Houston and these other programs that are out there for the betterment of the environment are really saying, what they're really complaining about, I would define it as they're complaining about
like 1% of the components.
Complaining about a 96% waste of time.
And then about 30% of the components have about 50, 60% of the emissions. And so, when you have a whole, 10,000 components,
hey,
only, only 100 that actually leak in a year.
Travis, am I getting a question?
Yeah, but that's the whole LDAR stuff is to identify.
Right.
Hey, Travis.
Right.
Yeah, hey, I'm not sure where that's coming from.
Prone to leakage than others.
They can be.
Okay. Yeah, I think maybe somebody's not muted, but I just wanted to make sure I'm okay, so I'll keep going. So as I was saying before, guys, we're saying that this is mandated work we're required to do. We don't really have a choice right now. And technically, right now we do have a choice. But normally we don't have this as a choice. So when I say it's a 96% waste of time, what I'm saying is that when you look at any facility that is if you're on the phone call and you operate any type of industrialized facility where you have volatile organic compounds, you have hazardous air pollutants as emissions, then what we're saying is that you do not, more than likely, do not have a 4% leak rate at your facility. Each one of your units that you're looking at are probably going to be less than 4%. Well, if that's the case, then that means that 96% of the monitoring you're doing is actually ineffective. It's not accomplishing anything. And add insult to injury to this, if you are at the 4%, then you're already on the radar. You already are on a short list, and that's no matter whether you with your state agency, TCEQ, LDEQ, whoever that may end up being, but also with the federal government, you're also on that radar, because the whole idea is that that number would be a bad number. But even in we're saying that this is a bad number, think about the other side. We're saying that 96% of the other work was done was a waste of time.
Hey, Brian.
So,
hey, real quick,
right?
Hey, real quick, let me interject. Hey, usually our attendees are all muted. That's the only thing I could figure. If everybody who's listening, if you could just mute your phones or your computers, somehow there's somebody who is unmuted.
engineering credits for my hours.
Trinity is
Somebody from our
Yeah.
audience is.
I'd rather sit here and get an hour or two than pay something somewhere to get.
I just, Brian, I'm so, I don't know who.
Uh-huh.
Aye.
I don't.
So anyway, if you are all the attendees, we've got a lot of people on here. If you could just please mute your computer, that would be great. Somehow, some way, I can't control it, so I'm not sure what's going on there. But all right, Brian, go ahead. Sorry about that.
All right. Well, apparently we can having new norms, so I guess what's one more, right? Well, this particular time right now is a time that's different than any other time that we've ever had before. Until September 30th, 2020, we had a rare opportunity to do monitoring in lieu of the requirements that we have written for our rules. So, I mean, in the worst situation, I guess you can do nothing, but in better situations, you can actually do something. And I think that in the industry, everybody's kind of chosen to do something. We'll talk about that a little bit later as opposed to like this particular opportunity that we have. So we've designed something that might end up being and could end up being the new normal. You know, it could be something that we get everyone, all of us get along, and it will be something that we'll be looking forward to and working on, you know, from this point forward, especially when we look at, as I'm gonna show you in the next couple of slides, the savings that can really be achieved while still achieving the same amount of compliance. So here, until September 30th, we have an opportunity to demonstrate through data that we can do this compliance another way that's way more cost effective. So let's talk about how we can really cut the budget, right? So the predictive leak management software system is something that we designed that would take all 3,148 of those components that were leaking, and we could have found those exact same leaks with a fraction of the monitoring that had to be happened. If you remember, the other side of that 3,148 was 600,000 plus monitoring events. By using a mixture of predictive analytics and your site's viable history, I'll stress that word viable. I probably should have put it in bold, but you know, if you guys have been doing your monitoring and running your monitoring programs on par, then with a carefully scripted algorithm by us, we can cut 50% of that monitoring and capture 100% of those leaks of those VOCs that are out there. That's what we're saying that can happen. So let's talk about how we actually would reduce emissions even more so than what's happening now. I have a couple of examples that I would love to share with you. So basically what we're saying is that the money that's not spent on Method 21, because you're not now in that 96% waste of time that we described earlier, and if I repaint that picture again, because I know it was a little cloudy back then, at a 4% leak rate, you are on the radar with US EPA, whatever your state agency is. And that's bad. If I saw through one of my audits a 4% leak rate, I would instantly wonder what's going on. You would think that they want to do something to get that leak rate down, right? But even if it was at a 4% leak rate, the other 96% of the monitoring didn't yield a leaking result, which means that 96% of that monitoring is what I would call now in our day and age a waste of time. We don't have to monitor 100% of the components to find 4% of the things that's wrong. We can use this module, predictive analytics, and actually come up with better results faster. And right now, because of the relaxation that's been given to us by the US EPA, we have an opportunity to actually demonstrate that on multiple fronts. And like I said, I'll talk to you about it in more slides coming up, but that's the premise of where we are right now. So the 76 components during this sample set that we talked about, the 3,000 leaks we were discussing earlier, 76 of those components leaked 10 or more times in that 4-year period. That's a lot of leaks that just leaked over and over and over again. 5 of those components, 5 of them leaked a combined 101 times during that 4-year period. So then you got to ask the question, did we really fix them? And I can see agency people, they would look at us and say, no, you guys didn't fix those components, what's going on? But if you are, if you're listening to me and you know what we go through on a day-to-day basis, then you know you have components that can go from, you know, several hundred degrees in temperature down to a lower temperature, or a pressure swing that changes over 500 or 600 psi. And what's fixed at one temperature is not fixed at another. And depending on which swing you come through and you catch these different things, you know, you can go back and forth on that all day long. So that argument can go on and on and on. But the real question is not, did you fix them, but why did or didn't you fix them? And there really is where the answer comes in. Because when you start looking at the whys, there isn't a vested reason, a good reason why industry should go into deeper fixing these components beyond what's been required within the rule. There is no advantage or no win on their side to dig deeper. So we'll talk about that in another slide or two, what that looks like to dig deeper when the incentive is, it's hard to say that word right now, incentivization is properly given, right? So let's take this case study that we're talking about. Previously mentioned, like I said, is a large oil and gas facility. The total savings there, if we were able to add that algorithm onto that database, would have been $748,000, okay? So let's just say half of that money is savings that you're able to keep. Like, just keep it. The other half, you turn around and you put into the 3,148 components leaking. More effective type of repair attempts. Actually, let's even scratch that and say we only focus on the 76 components that leaked over 10 times. If you look and see what the emissions are, you know, I'll go back a few slides and show you. This is how we get that 1% was responsible for 22, 23% of the emissions in the whole facility. This 1% here in the refinery was responsible for almost 40% of the emissions. 1%. That's not very many valves in that industry, right? So then if we can actually look at that and capture that population and do some more effective repairs, then that would make real emissions reductions, right? So as we talked about this facility, this is a large fractionation facility, and I'm basing it on the scuffs per day. And they had over 30 tons of emissions, in 2012. In 2016, this facility reported 56 tons of emissions. In 2019, this facility reported 41 tons of emissions. So predictive analytics and science can actually lower those tons of emissions significantly and at a much more reduced cost. So how do I kind of get in that? Let's kind of take a closer look. Let's open this up and see what we're really seeing. So in 2012, at 30.4 tons of emissions, that was at a cost of over $500,000 a year. In 2016, with 56 tons of emissions, is at an annual cost of $704,000 a year. So some of you are thinking like, okay, you had an increase in emissions, but it also increased in dollar amounts, which means that it increased in size. And the answer to that is true. It did increase in size, but it did not proportionally increase in size with the amount of emissions that it actually added. In this situation, there may have been another frac or two that was added. There were already 5 or so of them that were there. So when we look at this, that math doesn't add up to why we had so many emissions. And in the grand scheme of things, we're saying that we ran this program and we saw an increase in emissions. And in 2019, the facility, when it reported 41 tons of emissions, finally kind of started to get back on the right track, right? But let's look at what we're actually saying, right? We're saying two big things. First thing that we're saying is that program, we ended up having more emissions, not less. It kind of speaks to us focusing on what's happening with the repairs, right? But we'll talk about that. Then in 2016 through 2019, we were able to do a more effective job, and we were getting from 56 tons of emissions all the way down to 41 tons of emissions. Well, in that 3-year period, we spent $2.1 million to reduce emissions, and we ended up spending basically $140,000 per ton. I would not call this a cost-effective program. So my question still lies, is like, is there a better way? So if you look at it, once again, we'll dig a little bit deeper. The increase in emissions was not, as I said, due to just being a larger size. The number of DORs that increased at that facility was at some point almost rampant for valves that they could not fix. Many reasons for which I'd already talked about, as far as the pressure cycles, the swing cycles, the age of the valves, and in oil and gas, many times you don't really have control over when you shut down. If you're pulling off of a pipeline, you and I all know that you can't not pull out of that pipeline, because you would have liquids that would build up and will cause problems at a compressor station somewhere downstream. So they do have to run until they shut down, and then they take a maximum advantage of what they can take out of shutdown. And keep in mind, all of this is within regulatory requirement. All of this is by the rules that they were applicable to. This is what they did. So the overall leak percentage, also it might be mentioned, was never over 5% for any one unit. And as I mentioned before, when you get to that 4 or 5% range, it gets kind of dicey, right? You should be on somebody's radar. So they were never really on a radar for that speak from that standpoint. But still, the monitoring was ineffective by 95%. And we kind of talked about how I got to that. So with the Method 21 history and a carefully scripted algorithm, we could actually reduce that workload by 50%. Now, in this example, that's a cost savings of over $300,000. So what do we do as we dig down a little bit deeper? If we can actually do this, then we can take some of that money, if not all, and do the things that are not required for us to do from a regulatory standpoint now. And it's not for lack of trying. So don't think that the Sierra Clubs and Air Alliance Houston and the US EPA haven't wanted us to take these heroic or extraordinary efforts, but there's also a cost benefit factor that goes into any of these programs that they can put up on facilities in the United States, and that has never necessarily passed the red face test. But the fact is that these types of repairs are out there. So if I take $150,000 of this $300,000 I just saved for not wasting my time monitoring, then now I can go out at some of these extraordinary repairs. We do know and have seen that wire wraps work. And if you're, as a side note, if you're trying to get to the turnaround and the shutdown that the facility is going to have is 2 years in the future or 3 years in the future, and a wire wrap or a clamp or a composite wrap or boxes, all these things are things that we can actually do that are quote unquote heroic, that would literally stop the emissions in their tracks. It's not a permanent fix, but it'll get you to that turnaround where you're planning on replacing a component anyway. So if you're thinking about it from that standpoint, it sounds like we just saved ourselves some money, and we reduced more emissions, and we have a legal opportunity right now today to implement something like this that will allow us to put a paper together to give us an opportunity to have our voices heard, which might change the way we can do things. So the EPA is not unaware of this. As a matter of fact, I've been with Region 5, I've been to Research Triangle Park, I've been to Washington, D.C. I've had these conversations, and the end result of that has fell into, hey, we'll give you a project. So I had an environmental project that we did do in 2019. We did the legwork, we produced the white paper, we mailed that out to the US EPA, I believe, in February. And the things that it taught us was very, very interesting, which is why I'm able to actually kind of have this conversation with you today. I kind of do want to paint the picture of what we had to do, because we were not set up for success in this situation. The location was very remote, somewhere in the middle of Ohio and Pennsylvania border. It was not easy to get to. And it was a pretty long drive to get to where the site was. So that was a little bit extra cost that we weren't necessarily planning for. The sample product was mostly condensate. So we're looking at C3, C4s with a very, very light stuff, which is very easily to volatilize and already hard to keep in the pipes. So trying to predict which one of these was going to volatilize was not any easy thing, right? And then to add insult to all of that, the population that we were given to work with wasn't the biggest population. So I would think that if you ever had a ground zero situation or a worst case scenario situation, this might have been pretty close to that. I mean, we were looking at trying to find this trend over 1,000 components, which was, you know, let's just say it was very, very hard to do. So we were able to draw some correlations, and these correlations actually came to somewhat of a surprise. And I'm generally a betting man. I like the casino as much as anyone else, but I would have lost my money on the predictions. And the reason why I say that is because the type of stuff that I wanted to capture was, you know, vibration factors, temperatures and pressures, the vapor pressure of the stream, whether there was the swings, the pressure swings in the line, all these things that would give me some type of a clue as to what was going on, and see some correlations that I could pull out, you know. And to be honest, I mean, when we were looking at this, we definitely were able to use predictive analytics to drive the performance choices of what needed to be monitored. But, I will actually say also that we still want to draw these correlations from the leaking components. In the long run, that's really the bread and butter and maybe the sweet spot. But when we initially looked at this and we were one-sided looking at leaks, it really helped us more so to get on the other side. Not only should we be looking at why something leaks, but when we started looking at why things didn't leak, like I said, leaks do talk, but the things that didn't leak actually talked a lot faster. And that is how we were able to draw many of the relationships that we needed to draw to be able to produce something like what we have right now. So before, when I had all of the different characteristics in the database, which I think in the long run at some point you will still need, now with looking at the other side, like what things didn't leak and using the component history, and if you have 2 years, 3 years, 5 years in your database, some of you may even have as much as 7 or 8 years in your database now of monitoring history. All of that data is golden in conjunction with an algorithm that looks at it and rates those valves and can give you hot valves that you need to be monitoring because the likelihood of them leaking are very high. Many of our facilities right now are operating at losses. They're trying to keep their head above water. This could be an immediate stopgap that can be put in place today. I mean, technically, maybe not today, but put in place now because the EPA has given us the liberty to be able to do something that we think that we need to do to make this happen. So one of the things that really emphasized to me the reason why I really wanted to try to get this out there, and as I said, thank all of you guys for coming out and listening, and hopefully this wasn't too big of a switcheroo or whatever, based on whatever you read that made you sign up for this. So we were tasked with coming up with the emissions that resulted from the alternative method 21 that took place. So if we go back in our minds to late March when we got this decree, it was very timely and very, very much needed. And then we were all kind of basically scrambling. And for myself, I have a little less than 400 employees all over the United States. And that's a lot of programs to be juggling to try to figure out what are we going to do next, you know? And so most of the sites that we service really actually kind of handed down instructions to us. And then later on, we started doing some more consulting once we were breathing and you know, kind of got a handle on what was happening because this was all new, right? And what we found out is that not any of my sites that did anything differently than what I'm proposing here had more emissions captured. We actually, in our semi-annual reports, had to report that these are the emissions that we did not capture as a result of doing an alternate method 21, thus, in a way, proving to the US EPA that we need to keep doing what we're doing. And that just doesn't set well with me, knowing what I know, knowing what I've actually been able to submit to them. And I did talk to the US EPA late, maybe Monday, I think it was, And I know that they hadn't actually got to my case study yet, you know, but we did have a good conversation. It's some things we're going to be talking about and going forward. I'm saying right now that if we plan together, you know, for the people who would be interested, there is a way to cut your cost right now and do alternate monitoring plans that actually result in something that could be long lasting that may not have to stop in September. We could do the math, we could do the documentation, and then we can go forward with what you would have to do, right? So let's look at the big picture here. We have a sharp, rare opportunity to play with what I like to call is house money. You know, so if you're a gambling person, you know when you're in house money, it's actually the best feeling in the world because you're not losing, you're not risking really anything. You're only able to win with money that you got from house, right? And so having the opportunity to do a program as you see fit until September 30th is that same opportunity. They are aware that this method is out there. We've had these conversations. It is moving through, and it's something that is of interest that is going to be happening in many cases. This right now is a rare opportunity for us to put a really concerted effort into some documentation that can yield a great result all over. So I feel like we're experiencing a lot of firsts in our lifetime. Like for my career professionally, I've been fortunate enough to be able to do this for over 25 years. And I can honestly say, as I knock on wood now in my office, that I've never had a bad year. Every year has been better than the next year, from a company standpoint, from a personal standpoint. And that's one of the positive things about being environmental. I can tell you that this year, a near miracle may need to happen for that to be true. You know, I can go back 3 or 4 years and that might be where we end up at right now. This never happened before. US EPA relaxing penalties for monitoring activities, that's never happened before, ever. You know, and as I said before, no good deed goes unpunished. I can tell you that the woman who sent that email out, that blast, that notification, the memo, whatever you want to call it, received so many emails to her address that she had to she literally almost changed her email address. And the amount of heat that came from that, even with the sites where I'm doing these studies, you know, we have to very carefully move forward because it was a very touchy thing for her. She did that, and we needed that. I can tell you right now that as I'm operating all over the United States, I've never felt more like a house of cards than ever. You know, I have remote locations that are literally, you know, 800-900 miles, over 1,000 miles from where I'm at right now, and I got 2 people out there. And if the supervisor goes down with COVID, then I'm really I really got some really juggling to make. You know, we have already shipped people from Texas to Michigan and Illinois to Cincinnati area, from Ohio down. We have moved all over trying to you know, satisfy the requirements that are listed in the rule. And so we are very thankful for the relaxation that the US EPA has given us in this situation. And I'm just kind of suggesting that, you know, that we take it one step further. There is a legal way for us to be able to do this. You know, obviously the case needs to be started, but I'm asking the question, what is an email? I don't know if you guys have paid attention to it or looked at it, but for your LDAR requirements on the federal rule, in any one of the federal rules, there is an equivalence of means of emissions limitations that is there for you, and it is an opportunity. If you look through that and you read it, you're basically saying, or it's basically saying to you, that if you think that you have a better way to do it, that's going to give us the same results as what we have now, not better, the same, excuse me, the same or equivalent results that we have right now, we'll consider letting you do that in the long term. So what we have right now is a rare opportunity to do some investigation, some reporting, look at what it will look like for 1 month. If you took the month of August, excuse me, guys, if you took the month of August and you looked at it, then from this standpoint, there's no penalty to be received from the US EPA as a result of that. and you can start the trend and the paperwork needed to consider using this as a liable practice under an email. So that's pretty much the things that I wanted to talk about. Originally, I thought we had put this out already. So once again, I wanted to thank you guys for that. I wanted to close with some real things that you can actually do right now this year too, that would also help you, that are also not necessarily along the lines of, you know, the stuff that we talked about right now, but other things that are coming up that will be cost savings for you. Audits, when we do audits on third-party audits, so if you got a consent decree, you got to do a third-party audit. It's usually written in your consent decree that you have an opportunity to do it yourself, at least every other time. And if you haven't taken advantage of that, then this might be an opportunity to do that. When you look at audits, I mean, they can range anywhere from $18,000 to $30,000, and you can get a script from any of us consultants to help get that done for this year, right? And that will save you quite a bit of money, right? If you decide to do your own audit and pull in and follow the requirements that are given to you in your consent decree to be able to do that. You may want to also consider internalizing QA/QC. So if you are having like one of us come out and do QA/QC at the site on some frequency because it's required by your ELP or your existing CD, then that's another thing that can also be internalized. And mainly for the most stringent consent decrees, it just needs to be someone who's not doing the LDAR monitoring. So it may be something you may be able to bring in that could save several $1,000s in the course of a year. A camera certification is roughly about $3,000. So if you got a lot of camera monitoring, it might be a good idea to go through that camera certification and use it and do some of the monitoring for this year. That can save several $1,000s onto the bottom line budget. And lastly, I would say that remote QA/QC is a real thing. I talked to you about how to use predictive analytics to predict what monitoring you should do and what monitoring you shouldn't do. But of all the monitoring that's done, we can also use predictive analytics to have an expectation down to what route is being monitored by a technician. We could tell you how many leaks they should come back with. So if you were to actually use this on a remote basis, this type of analytical tool, which actually sits on top of any database, so all you need is that monitoring history, and you can kind of give you back our target list of things to go look at. Now you're doing some things remotely that would usually would be more time consuming and therefore cost money. And those are maybe some other things that I can kind of close it up with on being able to save money. So once again, I want to thank you guys for taking out the time to listen. I do truly appreciate that. And that concludes everything that I got. Travis.
All right. Well, that's good. Let me do the polling questions. There have definitely been a fair amount of comments and questions coming in, which is good. So if anybody has questions for Brian, let me do the polling questions first, just kind of get some interaction. But if you've got questions about your site and what you're working on, we'll get to that too. All right, let's see. First polling question. Let's see, I'll make sure, Brian, this is making sure that I've got yours up here, because I might not. I might have Jordan's actually. Hold on, come to think of it. I'm not sure, Brian, if you can see the questions that the polling questions I have.
No, right now my screen is showing me.
Are your questions regarding HAP?
Yeah, read the first question.
What does the acronym HAP mean?
Oh, that's his call. That's his polling questions.
Okay, sorry. Shoot. All right, let me, crap. We'll move to the next question then. Sorry about that, everybody. Because once I closed it, then I think I screwed up there, everybody. All right, so question number 2. What is the average percentage of leaking components in a refinery? So there we go. Good. Sorry about that, everybody. Looks like a whole bunch of you are answering questions here. This is good. So 2%, 5%, 1.5%, or 8%. So that's good. We got a whole bunch of different answers here, Brian. So that's funny. I'm assuming there's a right and a wrong answer. Is that right?
Yeah. So I had a grant. I kind of, when I sent them into her, I did give her like some multiple choice things, but that may have not popped up. So anyone who's less than 4%, because as we remember during the presentation, 4% or greater, you're in trouble. That's not normal. So if you said like anything less than 4%, you'd be right.
Okay, good. All right, I like that. All right, well, then last question. Sorry, everybody, I screwed up on the first one. The last question is, what are the benefits to predictive? Lower costs, the ability to reallocate existing funding to more intense, or increase safety due to reduced field exposure, or all of the above? So let me see here. Well, it looks like everybody's answering, Brian, but it looks like an overwhelming 98% are at all of the above.
Yes, all of the above. It does all of the above.
Definitely all of the above. All right, good stuff. Good. Well, let me get to some of your questions here because we definitely had a fair amount that were coming in. So some of them are just comments, but that's all right. That's good. Let's see. First one. One company that is vested in this problem states that pipeline components are not installed properly to begin with. Improper torquing, improper seals during maintenance are a huge contributor. There is virtually no standard during construction. FLIR camera studies reinforce this.
Yeah, so I would agree with that. The only thing I would add to that is that if you look at the torquing instructions for just about any valve that you put into service, the practicality of being able to execute that is very, very hard to come by. In our studies, and like I told you, we did all of these different tests on, the vibration factor and swing absorption and temperatures and pressures and everything. It really did boil down to, in many cases, the valves, the type of valve you put in that service. Obviously there are some standards that go by, but I don't think they're really looked at from how well they will hold the leaks, because there was a lot of correlations to be drawn with certain valves that come as a whole part of a skid that is just kind of implemented almost like a plug and play type situation, and the amount of leaks that came from that versus when we switch those valves out with other types of components that seems to stand the test of time.
Okay, good. Another comment was typically DOR components have to be repaired during plant shutdowns, which are far and few between.
Yep, I agree with that. I guess my point to that is that under this particular type of program that we have a free reign to do right now for the next couple of months, obviously the DOR part you wouldn't really be able to address in this time frame. That's kind of more of a long range goal, but the program as itself, as it runs, those components are also going to leak, and if we're going to be seeking email, which is what I have several of my clients in the process of doing now, then that equivalent means is going to easily be provable, because now, if I put a composite wrap around a flange and stop that, 12,000 ppm leak, think about how many emissions I've just saved that won't leak until that shutdown. And when the shutdown comes, I still got to cut it out or put a new thing in, but I have drastically reduced those emissions. And once again, like I said, I'm not wasting my time with all of the monitoring. What I didn't say in the presentation is there are thousands and thousands and thousands of components that have never leaked. And there's a reason why they did not. So if we're in any kind of pinch, we're in any kind of stopgap right now, this would be something to look at. You know, in September, you already got a COVID crisis. We all have that going on. We got crews, and you know, they're not together all the time, but they're working. You know, they calibrate in the same room, this close proximity. It's, you know, you may be forced with having to make some decisions, and I think that we can make some decisions that actually will help you in the long run.
Okay, good stuff. Here's a good question. Could you do a combination of method 21 and OGI? Use OGI on the components that are not expected to leak and focus method 21 on chronic leakers.
Yeah, so in the grand scheme, it may end up being something similar to that because you're going to go back and forth with the EPA on this. But the idea was that we would actually just, all components will get a method 21 once a year. So that's why we're at the 50% mark, and we don't. In some cases, we can do a little bit better, but in most cases, you're cutting 50% of your monitoring out. So you're cutting all your costs in half if you do that once a year, and then you only look at the hot ones on some other frequency quarterly, whatever you may end up doing. So doing it that way, we're absolutely going to capture anything that the camera would capture, so we wouldn't have to necessarily go to the camera. But in conjunction with how things work, it's highly likely that that might end up in the end result might be exactly what they said.
Okay, good.
So the answer to the question is yes.
Yes, all right, good, I like it. Another comment, doesn't it take quite a long time to get EPA to approve an alternative monitoring plan, like months?
Oh, it takes way longer than months.
Yeah.
I've been working on this for about 3 years now. And like I said, they granted the environmental project. We completed the environmental project with good results, and now we're moving on to the next step. The purpose of this conversation is that you can choose how you want to comply from this point now until September, to the end of September. I don't know if it's going to go
Oh, hey, Brian, we lost you there.
different. This can be done with your database and an algorithm applied to it, and you would go out in September and monitor literally half the components that, yeah, and you would save money that way.
Good stuff. Your audio for some reason all of a sudden kind of faded in and out, but you were fine during the presentation. We didn't that anyway.
Yeah, that was weird, huh? So
Yeah, it was weird. Not sure
okay,
what's going
yeah,
on.
so that
A couple more comments though. Doesn't industry have to demonstrate that COVID-19 was the result of non-compliance? EPA said that extensive detail must be provided to EPA documenting COVID-19 as the cause for not monitoring and non-compliance.
yeah, so it doesn't mean that you have to wait till you have something hit you in the front door, you know. So in preparation, and so basically most of my facilities have had some type of happening at the facility, and we've made all of the arrangements that we could make, and we're still moving forward. I have personally had, out of the 400 employees, probably 8 or 10 test positive somewhere in this country, and had to come up with mitigation plans as a result of it. So if you do it as a preventative measure for what is already happening, I mean, I think it would be hard for the US EPA to argue with 2 million people and the ease of contraction with COVID-19 as a reason, that itself as a reason why you want to take this step.
Gotcha. Okay. Let's see, another comment. Camera only needs to be certified if used for temperature, not emissions, e.g. methane. Is that right?
Yeah, I mean, I do understand that. I do agree with that, but it is a best practice and heavily scrutinized, especially in the GGGA, the Quad A monitoring that we do, the Subpart W monitoring that we do. They look at it differently. So I guess what I'm saying is, for one site, they're with all of the compressor stations and everything they had as a company, that was a $370,000 a year expense that this year is now going to be, 5 of the LDAR coordinators at, $3,000 a pop, plus they're already paying these guys and they're going to go out and do that same monitoring. And that's just the cost savings I was offering in that situation.
Okay, good. Let's see, EPA or not, the cost savings from not having product going into the air is cost effective. Fair enough. That's a good comment. Last question. Can you briefly explain the process of implementing the predictive analytics model?
Yes. So at a high level, without giving you all my cookies, for lack of better words, at a high level, we basically do an evaluation of the database, and we have two comparisons, right? We take on the one side everything that's leaked in every unit that's leaked, everything that did not leak in every unit that you have out there, and then we draw from that probabilities based upon the monitoring history of when leaks would occur in certain areas. And as a result of that, we're able to take out a huge number of the components and say we feel very, very sure that these components would not leak this month. So if we're talking about September, we would take that and say in September, we know that we can pull these components out. We are not sure about these components, and that falls into another category, right? And we're very sure that these components have a high probability of leaking. So now it's just a matter of these last two categories I just described. One of them, you for sure are going to monitor everything in there, because we can't effectively say that it won't, you wouldn't be able to find a leak there. And then you got the gray area ones that you can kind of make a decision on. And generally that decision is made on what the quality of the valve looks like, as opposed to how many leaks came from a previous manufacturer. There's a couple of the things that we look in there and try to capture. But if you don't have any of the manufacturer stuff, then we rely on the monitoring history, viable monitoring history, and the algorithm itself to do a marriage and spit you out a set of components that have to be monitored. It's just that simple.
Okay. Well, good stuff. Brian, we're going to move on. Well, it looks like, well, hold on, wait a minute. I spoke too soon. Do you use drone technology to monitor? So that's a good question.
That is a good question. So yes, drone technology now is being used to monitor at least the pipelines and different things like that. The difficulty with the drone technology is generally, I believe right now at best, you might have an hour flight time with the best batteries. So you got only so much you can do in particular areas, but that doesn't stop it from being a good opportunity or something that you can do. Now, once again, if you're really looking to use that, like for example, in very difficult places in the pipe band or the towers and things like that, that's still going to fall into an email. And we are in the process right now with a couple of our companies, large refineries, of getting that type of process approved and accepted.
Okay, good stuff. Yeah, we actually have a drone technology sponsor. You can find them on our website, Hill Equipment. But yeah, they've been deploying it up and down the East Coast for a range of different projects in the environmental industry specifically. But good stuff. Yeah, Steve says thank you. So one other comment from Daryl Christie, who I know Daryl. So he just says, I think the EPA memo says it will stop its temporary policy of relaxed enforcement September 1st, not the 30th. So that was his comment there. So,
Okay.
but let's, man, I really appreciate it, Brian. It's been really good discussion, a lot of great questions, but we're going to move on to Jordan. Hopefully we got everything worked out with Jordan's audio, but thanks for quickly shifting on the fly, Brian, man, really appreciate it. and being able to
No
jump
worries. Thank you.
All right, let's see. Jordan, let me hand things over to you. And maybe I need to close. There we go. I had to close the polling question. And Jordan. All right, Jordan.
There we go.
There we go. I can hear you now.
Fantastic.
That's good. All right, so I don't see your slides just yet, but I guess you're setting those up, huh? There we go. Back to where we started, right?
All right. We will keep this, pick this right back up from where we were. So what I was introducing here was just the topics we're going to cover. We're going to be talking specifically about sources now, source testing for these hazardous air pollutants. One of the big things to remember for the purpose of this discussion, we're assuming that there's some background in operating stack tests at your facility. This is definitely not a comprehensive strategy to developing a stack testing program. This is really a specific look into dealing with hazardous air pollutants. So the two big introductory topics here. One, there's 187 hazardous air pollutants that are identified in the regulation. These cover a range of types of compounds from VOCs, semivols, inorganics, metals, PM 2.5 ash, and the list goes on. There are some compounds that have been removed. I think there's about 3 or 4 that have been removed since the list was initially published, but it's down to 187. To regulate these 187 compounds, there are 204 subparts to 40 CFR Part 63 that cover it, and then there's 10 more from 40 CFR Part 61 that cover the hazardous air pollutants. The subparts are divided by industry class, so typically based on the type of industry you're in or the types of processes you have at any particular facility. It's narrowed down pretty quickly. You know, the good news is a lot of these, when you're trying to navigate, there's so many. It's not advancing here. There we go. In some cases, one facility or one type of process may have multiple subparts that apply. In a lot of cases, it's something as simple as, okay, you have your primary process, which you actually do at that facility, and then you have backup generators that are subject to different subpart requirements. The good news is, in many cases, the specific subpart is going to be mentioned and referenced directly in your operating permit as well. Some states are not as good with including that information there, and it leaves a little bit more digging on the facility side. The best way to kind of sort out which NESHAPs are applicable is to have a full copy of your permit reviewed by either your source testing vendor or your consultants, somebody to dig in and take a look. You know, the information that's in there really gives any test vendors the real key details that are needed to make sure they're properly prepared for the test. So once you've identified the subparts, the good news is some subparts specifically identify the HAPs that are going to be applicable. However, in some cases, the subparts do not detail specific lists of HAPs, and it is simply that facilities are responsible for testing and monitoring and controlling the emissions of HAPs. There's not a detailed list. In some cases, certain industries have specific lists that are maintained by their individual states. But as you can see, this has very quickly become much more complex than any other standard stack testing, RADAs, and other parts of, say, a Title V compliance test. So in some cases, it's mandatory that you have a detailed understanding and knowledge of the process. And this includes both the actual production, the actual process, what's actually the source of the emissions, as well as any control device that's installed on that source. Some cases, even after going through all of this, there's still the question, well, I still don't know what is applicable to my facility or my specific process. This can often occur during initial permit applications, saying, well, we don't really know what we have yet. It can occur if this is a novel process, if your organization has developed some new proprietary technology, some new approach to doing something that isn't captured directly under one of the specific subparts and just falls under a general miscellaneous subpart. Your permit's not going to have those details. It's going to be detailed engineering to try and determine what some of those details are. Oftentimes at that point, there's a consulting firm involved as well to try and investigate and navigate these waters and see what exactly we need to do here. Typically, in this case, it would require pre-survey or investigative testing to determine the target parameters, so specifically what are the potential hazardous air pollutant emissions coming out, the expected concentrations, and then if there's hazardous pollutants present, and we'll talk about what I mean there, and then preliminary source information. So in this case, when I say hazardous pollutants present, now I'm talking about for the safety of any testing crews or testing individuals that are there on this stack. So obviously the list of hazardous air pollutants as regulated by EPA is relevant, but there are many other hazardous concerns when you're talking about folks up at a stack ports to extract samples and do the testing. So this information here is really needed to develop and determine specific methods that are going to be used to perform the testing and specific back-end analytical approaches for those samples. The good news is most of these methods are actually pretty common to experienced testers because there is a lot of HAPs testing that goes on. Some subparts will also help us out by specifically identifying which methods are appropriate. There are some subparts that use the same language as the methods or just refer to the methods. But there are also instances where it's maybe not as clear. But the point of all of this is to say that because of the number of subparts, the number of potential HAPs, the number of ways that processes and control devices can be run, anything less than 2 or 3 planning meetings ahead of a test is really setting yourself up for a potential failure to be able to properly complete the test or to have the test results be deemed completely acceptable by the regulatory authority. You know, there's a lot of detail in specific processes and specific applications that can draw things out and make things different from details required in the subparts. And this is especially true of batch processes or a control device that may be controlling more than one source, as well as multi-stage control devices. And what I mean by that is sequential control devices. So maybe you have a oxidizer and a scrubber in series, or you have an oxidizer and a bag house. There may be different requirements depending on the specific subpart. The good news is some of the subparts will anticipate batch processes or multiple control devices and address them, but that is definitely not the case in all of them. And again, especially if you're operating a novel process, then you can not necessarily rely on the direct language in the subpart to determine what is going to be the most applicable. So to dig into the detail here a little bit, the 4 of the main classifications of hazardous air pollutants, it falls into one of these 4 groups. We've got VOCs, volatile organic compounds, semi-volatiles, which are organics, which have a higher boiling point or significantly lower vapor pressure and may not necessarily be gas phase at ambient conditions. We have inorganics, which comprises things like hydrogen chloride, hydrogen cyanide, hydrogen fluoride, and a bunch of other inorganics. And then metals. We have some specific lists of hazardous metals in addition to other wider ranges of metals that you may also have regulated in a permit. But generally, the bulk of hazardous air pollutants fall into one of these 4 categories. And as you can see here, I've just got a display. These are some of the most common methods, stack testing methods, that are used to perform these measurements. But it's very important to note that this is by no means an all-inclusive list. There are many more methods that may be applicable for specific compounds. The ones that I have presented here cover kind of broad swaths of compound lists and broad areas, and so they may be applicable to, in some cases, for specific compounds, even if there's a method that is specific to that compound that exists somewhere else. It may also be captured by one of these primary testing approaches here. So digging into it, the metal HAPs is actually the most straightforward and easiest example. So if you have metal HAPs, this is the way to go here. We've got one primary methodology. It's EPA method 29, which can collect just about any metal HAPs in one single sample collection system. So this is comparatively inexpensive to collect these samples. The analysis costs are not nearly as great as we find with the organics. Mercury can be included in this primary sampling approach with a slight modification that's actually described and written into the method. So it has the method as it exists includes the capability to modify appropriately. You can't do hexavalent chromium with EPA method 29. That would require a different method. But aside from that, you can get all the other metal HAPs with this approach. If you have a more limited list and maybe just includes lead, there's an even cheaper and easier approach, EPA method 12, which can be applied. But as with all of the HAPs testing, the planning stage, understanding exactly what the emissions limits are and having an accurate flow rate, estimated flow rate from the source is critical, because what the testing company needs to do is take that flow rate, find out what the laboratory minimum detection limit is, and make sure that the amount of sample volume that they collect when they're going after these compounds is sufficient such that a non-detect from the laboratory does not put you in a compliance issue. So having those full details is really critical. So once it's been determined, okay, these are the HAPs we need to measure, now we really need to make sure, do we know what a good flow rate is? Can we make sure that non-detectable results are going to prove compliance with your operating permit? So method 29, as with any of the other integrated sampling approaches, can be modified simply by increasing the gas volume that is sampled, which in practical terms means extending the run times. But it can be modified so that you can drive the in-stack detection limits much lower, and really your only limitation is the laboratory analytical limit, but the sample trains can collect significantly more volume than the minimums described in the methods. So I'm going to move a little bit faster here and just jump right into semi-volatiles. So the next major classification of HAPs falls into the semi-volatile category. And again, we have one method, it's SW846, method 0010, which is very versatile and can have has quite a large analytical compound list. So you can get a lot of semi-volatile HAPs from a single sampling train. The good news is this is a very common train in the sample collection train in stack testing. It's also used for dioxins and furans. It's used for a few other primary methods. It can be combined with a particulate matter test, and it can really be versatile for covering a wide range of things. This is also good if you don't specifically know what the rest of your HAPs are. You may know through identifying the process and information that you have these semi-volatile HAPs, but you may not know, well, it could be any number of things in this range. The good news with this approach is it is a GCMS analysis. So it is possible for the laboratory to perform additional analysis on it. They'll look for a pretty significantly large primary compound list, but then they can also expand to then search a spectral library for other things that have shown up here, which can be very helpful, especially in a planning stage, if you are uncertain of what the hazardous air pollutants are in the specific source. So when they do that, it's called a tick scan. This is a tentatively identified compound scan, and they have to qualify it like that because they're not calibrating for these compounds, but it can tentatively identify these compounds. If it's going to be used for compliance purposes, the best practice is to then follow up with a specific analysis for those compounds which were found to get a high quality result on what those actual levels are. In some cases, it has been deemed acceptable to go just by the tentative identification steps, but in general, that's not a great practice because different compounds have different responses, and the tick scan kind of flattens that out, so you don't see a true response. So it's generally described as a semi-quantitative approach where they can give an idea of relative levels, but for using that as an actual final number is definitely a bit risky. The next one we're going to look at is the organics and volatile inorganics and volatile organics. And we have a very special case here with EPA method 320, which specifically the method is vapor phase organic and inorganic emissions by extractive FTIR. So this is really handy. We have one method that can be used for a broad range of inorganics and volatiles. I've got a list there of some of the most common applications. So we cover the three of the primary inorganic HAPs, as well as a range of some alcohols and aldehydes, carbonyls, and other specific HAPs. The nice thing here is a lot of these compounds do have other primary approaches that are specific to them. However, if you have multiple, you determine you have multiple HAPs that could be present, this gives you some flexibility to capture a lot more data in one go. The main point is that this works the best for compounds that have strong infrared interactions with minimal overlap. So they're absorbing infrared light in very specific wavelength ranges to follow up with an infrared analysis here. And the other good news about this is an absolute measurement. It's based on the physical properties of the individual molecules. So there's really no ambiguity of, hey, how right is this number? That said, there can be a lot of it if the method is not applied correctly. If the method is applied correctly and all of the QA/QC is done and everything looks good, there can be no ambiguity about it, and you have a retained sample that you can reevaluate and you can look at again and you can show to anybody who asks or who questions it, which is what really makes this stand out in contrast to some of the other historical methods, typical methods that are used for some of these compounds on an individual basis. So one of the other benefits here is there's a minimal need for calibration gases on site. There's some things that must be done to successfully perform a test, but just because you are testing for, 5 or 6 different HAPs at one time with FTIR, you do not need to have 5 or 6 different calibration gases on site, which helps with the costs of actually performing the tests. All of the calibration is stored in a library on the computer that's running software that has an algorithm that's evaluating the results. So you end up with these data files that represent your actual samples, and your reference library that's being used, and the algorithm that's being used to apply that reference library to those spectra to get the results. One of the other things that kind of makes this stand out versus some of the other instrumental methods is that it's performed on a hot-wet basis. There's minimal conditioning, and you get the results live as you're there, as your testers are there on site, versus method 26 if they're doing HCl and then maybe they're sending it off to a laboratory, or we get into method 18 and we're speciating volatile HAPs and they're waiting for laboratory results. On the flip side, there are a number of applications where this is entirely inappropriate, and it really comes down to the understanding of the technology and the methodology by the stack testers to help guide facilities to whether or not something is appropriate. There's a lot of cases where compounds start to overlap, and it becomes more difficult, and we'll address that. Just to show a brief example here of the spectra and what we mean, this top image here is a close-up of HCl through a wavelength region where it's typically analyzed. And so there's 2 different examples there. They're just overlaid, and you can see there's a calibration file, which is cyan, and a source sample, which is green. And you can see there's very clear in every place along this region where these things overlap and are matched appropriately. And then the bottom image is just zoomed in on one of those specific peaks to show how well these things actually line up. So there's a little bit of an offset at the bottom, but otherwise this is used to scale the calibration file with the sample file to actually get your measurements there. One of the other things we start looking at is VOCs here. This example provides a handful of different organic HAPs, as well as there's some other non-HAP VOCs present, but this is a typical combination for ethanol or other fermentation processes here. We've excluded water and a bunch of other things to kind of clean this up and make it easy to see, but what we notice is as we have more compounds that are similar, we find more areas where the absorbance actually overlaps, and it can become more difficult. An experienced stack testing team will be able to identify these areas, look and see if there's better areas to get a good quantitation, or determine what is the impact on the error values of the overlapping absorbances. But that's really where FTIR can fall short. The absorbance that's actually measured is dictated by the bonds within each molecule. If there's more similar bonds, it can cause some interference. So for example, if you have methyl cyclopentane, you have a C6, and then you have a hexane, you have in both cases, you have a bunch of carbon-carbon bonds, a bunch of carbon-hydrogen bonds. There is a little bit of a difference with the conformation of the molecules, but you end up with a lot of overlap. And this can really start to make it difficult to attribute appropriate error amounts to each type of compound. We have other things. There's high infrared absorbing species like water and CO2 that can cause interferences. But ultimately, when you have these interferences, you end up with a combination of different types of uncertainties that can make it very difficult to determine low-level results. And in some cases, it's a simple thing of having a more powerful instrument. In other cases, it's the case where overlapping compounds inherently add error to individual measurements, and regardless of what instrumentation may be used, if that error is properly accounted for, you may not be able to achieve acceptable data quality objectives. Moving right into the other primary classification, method 18 for volatile HAPs. Basic concept for volatile HAPs is it's a GC analysis, typically with an FID, a flame ionization detector. There's 3 ways to collect these samples, and each one has its own specific utility. But to perform any method 18 testing, you definitely must have pre-survey testing performed, or you must have very reliable data that is representative of the process as it's operating today. So a detailed high-quality report from 25 years ago may not satisfy, because there are more than likely there are things that have changed either with feedstocks or other things within the process that could really impact the levels and potentially even the types of compounds that are coming through the process. So just to give a quick run through of the approaches, the 3 primary approaches, there's the Tedlar bag approach, which is often the most commonly employed approach. It's great because in this case, you can, after the analysis is performed, then the QC steps are taken. So you have good insight into exactly what's there to perform the QC. It's not great for certain types of compounds. It's best for ones that have high vapor pressure, low reactivity, and low boiling points. So if we identify our compound list, this is a pretty useful approach. Adsorbent tubes have a much wider range of applicability and can be used for an even broader range of types of compounds. It's great, especially for polar compounds or other ones that may have issues recovering from bags. The other huge benefit here is it's an integrated sample. So this is the approach that can be used to drive those in-stack detection limits down much further. The downside is you need to know almost exactly what is there before you do the test. This is a case where pre-survey testing is pretty much mandatory unless, again, you have extremely reliable previous data, because the QC requirements call for QC samples that must match very closely to the source matrix to be able to qualify the actual results. Third primary approach is direct interface here. Direct interface is great for reactive compounds because now we're not worrying about collecting a sample and transporting it to a laboratory. We are directly analyzing sample from the stack through a heated sample system. It also has the least restrictive QC measures of the three approaches. Essentially, all of the instrumental calibration requirements are the same regardless of which approach you use. But in this case, the only other real QC that's applicable is a line loss check, where they're just making sure the sampling system is actually delivering the target compounds. So on the downside, this is typically the most expensive approach because this involves bringing a GC and an experienced GC operator on site. They need to bring all the appropriate gases on site, so they must know before coming out exactly what the target compound list is going to be. And if there's things there that aren't on the list, they're kind of stuck with being able to, and not necessarily being able to quantify those results. So the key, all of this is to really say, given this broad variety of types of compounds and analytical approaches, and then some of the extreme detail within each of these just these 2 or 3 primary approaches we've just discussed, I think it paints a very clear picture that this is very complex. And if the planning stages are not performed correctly, or if there's hesitation to share information, then it can very rapidly lead to deterioration of a test quality. So with that said, there are instances where you end up with unexpected results. So let's say, well, we did all of the planning and we came up with, we made sure we're following the right subparts. We figured out which HAPs are applicable to us. We sorted through which methods to apply here, and we understand the caveats of the different approaches within the methods. And then we ended up with results that don't make sense. Types of unexpected results, oftentimes results that appear to be out of line, whether it's run to run or out of line with historical data. In some cases, they may look out of line with mass balances or other predictors. You say, well, it's impossible for there to be that much there because that much isn't going in. This typically comes down to some shortcoming on either the facility side or on the side of the testers in the laboratory. From the facility side, it's not uncommon for there to be changes in facility-wide operation. Maybe there's different products being run. Maybe something has been tied into another system that was not previously like that. Maybe there's been a change in feedstocks, things that are being used, a change in fuel suppliers. If you're burning coal and your coal is coming from a different part of the country or meets different quality standards, that can have an impact here. And then the actual application of methods. The facility may say, yes, well, this is the method we used previously. This is the method that needs to be used now. And through more detailed planning, it could have maybe been discovered that it was not the most appropriate approach. On the testers and laboratory side, there is definitely the possibility there are issues with the actual sample collection. How do we know the samples were collected appropriately? Were they handled appropriately? What analytical techniques were selected? And the same thing, if the testers select methodology that may not be the most appropriate or the best methodology for something, that can definitely lead to unexpected results. You get things that just, it doesn't quite make sense. So fortunately, again, many of the subparts will specify with which methods need to be employed, but in some cases, the methods that are required in the subparts may not be the best or most appropriate methods. In many of these cases, it's very clear that other methods may be appropriate if they're approved by the test administrator. And that's definitely a case where strong advocacy with regulatory bodies can be very helpful to kind of discuss with the regional office especially, and then the state, hey, here's a reason we want to do this other approach. We understand this is what the subpart says, but we believe this is going to be better. We have a different method that's been validated through method 301 and is possibly more applicable. However, in the case where we're pinning it on the sample collection and sample handling, and there's a failed QA/QC issue, it really causes big questions of what are the actual implications of failed QA/QC, because in not all cases does it mean that a test is invalid. It depends on what types of QA/QC fail, how far out from the restrictions the failure is, and is there a way to determine what the potential impact is on a test. So in the case of duplicates or failed spikes, it could point to sample collection and sample handling. If there's leaks, hopefully if there's leaks, your testers identify that on site and repeat the run at the get-go. But it requires some investigation to get into what are the actual causes of the specific failures, because there's many opportunities for a failed QA/QC set that could play into the final result. Who must address? I mean, obviously it is a joint effort between the facility, the testers, the laboratories that were involved, and the regulatory bodies. In some cases, it may come down to a discussion with the regulatory body and discuss what the supposed cause is, or if any additional investigation has been done, additional testing or of equipment or testing of procedures, additional blanks that maybe the methods don't directly allow for blank correction, but if it can be proven that there's some systemic bias, it can oftentimes be acceptable as well. And so after that type of investigation, going through and developing an actual path forward, say, okay, well, what needs to be done? What can be done? And as I said, in many cases, it does not necessarily result in an outright rejection of a test program. Oftentimes, it results in submittal of additional comments or a report addendum to address specific concerns or specific issues. And then there is ultimately the possibility, though, for additional testing. It may not be a full repeat of a test, but it may require some additional samples or types of samples or portions of tests to be collected. So again, all of this is really to kind of illustrate some of the complexities with HAPs testing and to understand why these programs take the time to develop, and they're much more expensive than any of your other testing needs facility-wide. These become the most complex types of tests, and the costs do escalate pretty well proportionally with that. So I do apologize for having to kind of run through that, but I didn't want us to get too long here. So I guess we will open it to questions, Travis.
Yeah. Let's see. Let's do the polling questions first. Again, everybody, if this is, as you're listening to Jordan, this is a good time to put your questions in the comments. We do have a couple questions that have come in, Jordan, while you've been talking. So let's see. Let me do the polling questions. So, what does the acronym HAP mean? Four different options there. Looks like everybody's getting this one right.
Yay!
It's interesting, on most of our webinars, our speakers are kind of given like a multiple choice with like not really a true or false. It's more, pick one. what you're dealing with type of a thing. But these are good. I mean, both you and Brian did kind of more of a true or false type of thing. But hazardous air pollution, yes, that is. I was going to show, trying to figure out how to show everybody the results. But anyway, 100% said hazardous air pollution. All right, so next one is what are two of the common classifications HAPs fall into? So select all that apply: metals, VOCs, SVOCs, inorganics. That's good. That's good. Looks like everybody's responding. And I'd say, looks like, Jordan, we've got about 95% of the VOCs with VOCs, and another 50% each with metals and SVOCs, and about another 40% saying inorganics.
Well, I can't see the polling questions, but based on the way you read it, it sounds like all four of those answers are the correct answers there.
All right, so there's no false. That's good. All right, and let me see how. Last question for everybody. Let's see. All successful stack tests should start with detailed what? It says that your question actually says tack test, but I know it means stack test. Sorry about the typo there, folks. I'm sure everybody. So select one. All stack tests should start with detailed such. What is that? Looks like pretty much everybody has responded now. Planning, 100%. Everybody is saying planning. All right. Well, good. I will close those out and leave it. So we've got your page up there, but we do have some questions that have come in. So give me 1 second here. Okay. Why do some stack tests only, let's see, some stack tests only a hydrocarbon value only, and some includes a VOC value? What determines that? Why not always give both and include HAP?
The differentiation between total hydrocarbon and VOC and then how that applies to HAP is a very complicated situation. Some regulations are specific to total hydrocarbon. Some regulations do not talk about VOC, they talk about total hydrocarbon. So typically that's the reason something may not include VOC. Now, the way that VOC is measured broadly is with an approach that measures total hydrocarbon, and then non-VOC hydrocarbons are measured separately and subtracted from it. There are some other analytical approaches that kind of squirrel around that a little bit, but that's the predominant approach. So in a case where a permit specifically calls for VOCs, that may be the approach. Now, in some cases, for a request that calls for VOC, it may be determined that to measure VOC, a total hydrocarbon approach is not appropriate, and a speciated VOC measurement may be performed, and you get a summation of specific VOCs. So kind of like the opposite. Total hydrocarbon, measure all the hydrocarbons, subtract things that aren't VOCs, or measure the VOCs and add them together. When we talk about HAPs, it gets a little bit more different. In some cases, if you have very low VOC or hydrocarbon emissions, then if you may be able to just test for, hey, total hydrocarbon, look, my total hydrocarbon is less than my HAPs limit, so I must be fine for HAPs. Some states will accept that, others will not, and in some cases you may not want to do that because you may have VOC emissions in excess of your HAPs, your specific HAPs limitations. So you may be greatly overestimating your HAPs there.
All right. Good stuff. Let's see. A few more questions are coming in, but here's another one. For a wet method, such as methods 7E and 10, there is a way for regulators to verify the test method was done correctly. What is available to verify method 320 using an FTR was done correctly?
Well, so the good news is, right, with method 320, you end up with an actual sample, and it's the spectrum file that's generated from the actual collection. So you have this raw data file that you can go back and it's very easy to take a look at that and determine, first of all, is the algorithm that's being used correct? And then secondly, through analyzing the spectra from the QC steps called for by the method, it can be very readily apparent whether or not someone properly tested their sampling system, they've properly validated that compound for that specific source. The big failing here is the fact that many regulatory bodies do not have the understanding or the experience to be able to make those determinations independently. They may understand and say, well, this is what is required by the method or the footnote to the table in the subpart, but we don't understand what exactly it's asking for and how to evaluate it. So it is a little bit unfortunate that the many regulatory bodies can't actually, like, it's possible and the data is there and it's more clear with a method 320 test than any other instrumental approach, but ultimately without the right knowledge and experience to actually be able to evaluate that information, it may leave many states and many places kind of in the lurch on being able to qualify those. And so as a result, there are some states, one state to pick on Tennessee in particular, pretty much flat out refuses to allow FTIR testing for compliance purposes unless it's very, very specific cases, because they recognize that they do not have the capabilities to properly qualify and review those results.
Good stuff. All right. Another question. They keep coming in here. Why did the EPA exclude HCHO from VOC testing for like NSPS?
Can you give me that one more time, Travis?
Why did EPA exclude the HCHO from the VOC testing?
Well, formaldehyde is excluded from a lot of VOC testing for the simple fact that it simplifies the way testing is done for VOCs. So if you're using one of the primary VOC approaches, which is 25A, which measures the total hydrocarbon, and you're subtracting non-VOCs from it, formaldehyde doesn't show up by that approach. You can have hundreds of parts per million of formaldehyde in a gas stream, and if you do this flame ionization detector approach, you will see almost nothing. Where we can be sure that, well, we know it's there. So it gets excluded from VOC. I think that's mostly a point of convenience. Some states actually ask you to add it back in. In some cases, it's saying, okay, your total VOC is your 25A plus your formaldehyde numbers for certain types of industries. But then formaldehyde is definitely grappled with strongly in the NESHAPs instead of the NSPS, because it's ultimately determined as a hazardous pollutant. And a lot of times we see formaldehyde and we see methanol, acrolein, and acetaldehyde. Those four kind of all together there in the in HAPs regulations.
All right. Somebody made a comment, the VOCs are defined in 40 CFR section 51.100. I guess that was in regards to something you were saying there. Another question, why was EPA resistant to using the M320 FTIR and wanted to remove it back a few years back as approved test method?
That question sounds like it's specific to Quad J, which is an NSPS regulation. So hopefully I'm interpreting the intent of the question correctly there. Because overall, EPA really does enjoy Method 320. So the folks down at Research Triangle Park, they have the knowledge and experience and capabilities to properly evaluate FTIR results. So they really like it because it gives them more information than other tests. It's very beneficial for facilities for a number of reasons. But overall, they like the method. The exclusion of it was in regards to doing total VOCs on natural gas fired engines under NSPS Part 60, subpart Quad J. What they were after there is because they were acknowledging that the method is only appropriate when you have a defined compound list. So what FTIR is not good at is proving that something is not there unless you know exactly what it is that's not there. And that's where it kind of fell apart. In general, the types of compounds that show up in the exhaust from natural gas fired engines is kind of a mix of hydrocarbons. And you get these things that have overlapping absorbance, which I touched on briefly. And basically, if you do it properly and add up the actual error values for those measurements, you would most often end up with results that are much higher than actually being emitted from the sources. So what EPA was attempting to do was say, hey, this is being misinterpreted. We really only wanted this in here for methane-ethane subtraction. It got expanded to doing a total VOC number, but you can't actually satisfy the requirements of the method on this source matrix, satisfy the validation requirements. And if you dig deep into the FTIR protocol, you find that that is true. You can't actually qualify those results by the method on those sources. Ultimately, that removal was met with some pretty strong opposition, some conflicting arguments about costs of testing, and they opted to leave it in for now, but they did also highlight that on the next RTR for the subpart, they're going to evaluate it again. And if I had my guess, they're going to try again to take it out of there for that specific subpart.
Oh, wow. All right, I know we're over time, but last question here. Do you have to trust, do you have to trust the site is running by normal operational conditions, or do you have a way to validate that? Is this with a regulator?
So normal operating conditions can really vary by industry, and it really depends on what's being done there. If they operate certain kilns at certain temperatures or certain types of products are made, then it's as simple as verifying, okay, here's what is normal, here's what's average for the facility, or in some cases, here's what's the worst case for the facility. And then compare those things. You're comparing, if they're baking something, comparing the recipes that are in there. If they're making bricks, same thing. Compare the recipes that are there, or the kiln temperatures, oven temperatures, line speeds for printing things, airflows. Like, there's so many possible ways. Fuel consumption, they can be used to see, is a facility operating at what would be considered a normal or a worst case scenario, for the purposes of testing. Now, generally, test firms, stack testing firms are going to rely on the facility to confirm that and provide that information. So, from a tester perspective, yes, I'm definitely going to trust the facility because they have access to all of their records. They know what's normal and what causes different things to happen in their process. From a regulatory standpoint, it definitely could involve some digging. Hopefully, it's just as easy as going to the permit application and the documents that were submitted when the permit was obtained to identify, hey, here's what the expectation is for how these things are run. And the permit's going to say, okay, and these are the things that have to be monitored. And as you're monitoring those things, you say, yep, this is normal. Everything's normal here. We're good. Or you say, well, we're actually not running under normal conditions right now, so we can't test right now. We need to change some things up and make it normal. Or maybe there's some upset going on, and it's like, well, this upset is clearly not part of our normal operation, so we need to hold off on testing until this gets sorted out.
All right. Well, good stuff. Yeah, he says thank you. So that clearly answered his questions. So that's good. Well, thank you both. I think, Brian, you're still here with us. Thanks, Brian and Jordan, both of you guys for speaking.
Thanks for having us, Travis.
I think both on both questions, we had people asking about slides. And so what I always say is just email the speaker. So I think majority of people that had registered are still on here. And so if you want the slides for either Brian or Jordan, just email them directly. Brian, you want to give your email address again?
Yes, it's Brian, my name, BRIAN .Whitley at EMSI-air.com.
Perfect. And I know your profile and everything, your email should be on our website too, but that way people got it. Jordan, how about your email?
All right, it's Jordan, JORDAN .Laster, LASTER at stacktest.com.
Perfect. Well, good stuff. That answers that. That was the kind of like the final question, but we always get that on every webinar. Can I get the slides? And I'm always email the speakers. That's probably the best thing. And I'm sure you all out there, you probably have more questions for them too. So just email them, ask for the slides, and if you got more questions, keep them going. That's why we're here, is to answer your questions. So, well, thanks guys. Appreciate it. I know we're over the time limit, so I will let everybody go. Everybody have a great day.
Thank you.
Thanks.
All right, thank you.